Welcome back. Today we dive into structural pattern matching, a powerful feature introduced in Python 3.10. This feature enhances Python's ability to handle complex data structures and control flow, making your code more readable and expressive. Let's go. Let's dive straight into it. We define two functions, greet if else and greet. The goal of those functions is to greet someone differently based on their name. So if the name is Alice, we print hello Alice. If the name is Bob, we print hi Bob. And if the name is something else, we print nice to meet you with the name. In the greet if else function, we use the usual control flows with if, elif, and else statements. And now the interesting part. The greet function uses structural pattern matching. And as you can see, it works with two keywords, the match and the case. So with the match, you define on which variable you will apply the pattern matching on, and with the case, you define the pattern that should follow the variable to match your case. So here we say match on the name, and in the case where the name is Alice, return hello Alice. If it's Bob, write hi Bob, and then we use a wildcard pattern to match all other cases and print nice to meet you with the name. We can run this cell and see that it works as expected. In this simple example, we already see something interesting. We do not have to repeat the name of the variable and the equality in pattern matching. You define one time the variable, and then you just express the cases. And it's a super simple application of pattern matching. Now we are going to see 9 different features you can use to use pattern matching at its full potential. And we start with literal patterns. A literal in programming is a notation to express a fixed value directly in the source code. Here, we have a simple example where we match on the value and we define 3 literal cases. We match on 0, 1 or 2, or the hello string, and we display something different each time. If we run the cell, we can see that it works as expected, writing 0 here for this case, 1 or 2 for 1 and 2, and greeting in the case of hello. Super simple. Then we have capture patterns. Those ones are really powerful because they allow you to match on a specific shape of a data structure while also capturing different parts into different variables. So let's take a look at this example. We have tuples that represent points in 2D or 3D. So the tuples have dimension 2 or dimension 3. With pattern matching, we can match on the value and extract tuples of 2 dimensions and the x and y component into 2 different variables at the same time. So here, the case xy will capture only tuples of size 2 and will extract the first and the second component into the x and y variables. Then we can do the same for the 3D case with x, y, and z. And as you can see, it works as expected. This one can go crazy, so you can match different type of arrays, tuples, dictionaries. We are going to see that in the future sections. Then we move on to the wildcard patterns, which are pretty useful when you don't care about the value you're capturing in the case statement. So here we match an empty list, then a list with 1 element of any value, then a list of 2 elements of any value, and then more than 2 elements. You can run the cell again. And as you can see, we match the different cases as expected. Next up are the sequence patterns. In this case, we match an empty list. Then we match a list with 1 element, and we capture all the other elements into a second list by using the star notation. So here, if we run this cell, you can see in the first case, we have the empty list, simple. Then we match the first element. In the first, we display it here, so 1. And we display the remaining elements, so an empty list. In this case, we have 2, 3, so we match 1 and then the list 2, 3. This pattern makes complex cases look simple. Similar to sequence patterns, but for dicts, we have mapping patterns. With mapping patterns, you can match specific keys, but also capture specific values. So, in this case, we match on the value, and we express the first case as a dict that should have a name, then a value as a string, and an age which has a value as an int. And we capture the name and age in 2 different variables that we can use in the body of the case statement. So here we print the name and age years old. Then we match dictionaries that just have a name, which is a string, and finally just have an age, which is an int. So if we run that cell, you can see that it works as expected. And as you can see, it also makes complex data structures with complex control flow really simple to express. The next ones are class patterns. They allow you to match against objects of specific classes and their attributes. Here we define a class named point with two attributes x and y. Then we match on different cases. First, the origin, so x and y equal to 0. Then we match on x equals 0 and any value of y, then the opposite, and then on any point, finally, we match all other cases where the variable is not a point. If we run the example, we can see that it works as expected. Then we have OR and AS patterns. OR patterns allow you to express OR condition within a case statement. So here we match between 0, 1, and 2. As you can see, for 1, we go into that branch and display low number. AS patterns allow you to rename a variable. So in this example, we analyze pair, and we want to match all pairs that start with any values and have 3 as the second value. But we do not care really about the different values specifically, we just want to print the entire pair. So what we can do is we have the case, which matches with the wildcard, the first dimension, then 3, and we rename the entire pair as code that we can display here. You can see matching pair 3, 3, because we display the entire tuple, and then the default case. And finally, we have guard patterns. Guards allow you to refine your case statements. So in that case, we match on the age of someone, and we first check that it's an integer. We capture the value in a variable n, and then we use a guard to refine that statement with a condition. So here we will check that n is below 0, then that n is below 18, and so on. So as you can see, guards are just a way to further refine a case statement with a condition. If we check there, we see that it matches as expected. So now let's compare traditional if-else statements and structural pattern matching in a more realistic scenario. Let's say you want to build a command parser that parses 3 types of commands. First, quit to exit. Then you want to parse hello, you print hello world, and then hello with another name, you print hello and the name. Other cases, you print unknown command. Using traditional if-else, it's a bit cumbersome to read. So here you have the if, the elif, then you check that the command starts with something, you have another if to check if the length is greater than 1 or not, and so on. With pattern matching, it's much more clear. So here you match on the command split, so on the array of keywords, and then you have a first case where you contain only the quit value. So here you return exiting. Then you match on hello and the name, then you match just on hello, and finally you have the end cases, which is really easy to read as you just express patterns instead of stacking if conditions. And finally, to show you that you get the same results, here is the command with quit, hello Alice, hello and help, expressed with both the if-else and pattern matching approach. And as expected, it's equivalent. Structural pattern matching is a powerful addition to Python that can make your code more expressive and easier to read, especially when dealing with complex data structures or control flow. And as we saw together, it offers a wide range of possibilities beyond simple switch case equivalents. I hope I convinced you to use structural pattern matching in your next Python projects. See you in the next one.